Hi guys, sorry the session was a little late. I guess people are kind of tired after a long day. So today in my talk, I'd be covering about progressive delivery on Kubernetes. Now, just by a show of hands, how many of you have worked or know about Kubernetes in general? Great. So majority of you. So in my talk essentially what I'm going to be doing, right, is essentially talk about what progressive delivery is, what are the different types of progressive delivery, and then I'm going to focus on canary releases and what are the challenges that organizations typically face when trying to implement canary releases. Then we're going to cover service meshes, what service meshes are and what are some of the benefits that they provide in an enterprise environment. And then we're going to look at a sample pipeline, how progressive deployment may work in a practical environment, right? And then we'll have some sort of demo and then start with the Q&A, right? Cool. So let's talk about what is progressive delivery. So traditionally, enterprises have deployed software into the compute platforms, primarily going to be, infrastructure as a service, which are your Linux servers or Windows servers. But in case of, where in those earlier legacy deployments, as we can call them, which is pre-containers, pre-Kubernetes, it was pretty easy doing these kind of canary releases because you have certain sort of a fleet of instances or a fleet of servers running, and then you can easily control, traffic deployment through the CI software directly. But in case of Kubernetes, in case of containers, which are highly dynamic environment, how do you control, traffic to a granular percentage level is what, a big challenge that has started to emerge. So what exactly is progressive delivery, right? So when you're releasing new changes to a new software, let's say you have an application running in Kubernetes, right? It's running as a deployment. When you're trying to release new software to this particular application, you want to ensure that these new features and new code that is getting deployed, while it has passed extensive unit tests, also pass extensive user acceptance tests, right? And you want to do it in production. So there are two ways you can do it. One is where you deploy it directly to production and roll back in case something goes wrong. But of course, we know how that goes most of the time. So what we want to do and what a lot of companies have started to do is it has started to roll out these things gradually to a specific set of individuals, specific set of users, specific group of users. Just earlier we had a keynote from GitHub. So what GitHub does, GitHub deploys in circles, right? So let's say a new feature which is customer facing needs to get released out there in the world. First, what it does is it deploys it to a certain group of individuals. Then it keeps increasing that in concentric circles till the point that it reaches it reaches the end users. So essentially, that's what progressive delivery essentially stands for, right? So there are multiple forms of progressive delivery, right? So what are different forms of progressive delivery, right? A/B testing, which is essentially you have an A version of the software, which is the stable tested version, and then you have a B version of the software, which is the new version that you're trying to release. It may not be as important as when you are doing small releases, right? But when you're doing anything major, when you're releasing anything major, you want to ensure that you are testing it out with the right set of audiences, to the small set of users, to ensure that you're catching errors, if any, early in the process, right? Blue-green testing also similar, and then canary testing, right? Canary testing is becoming a de facto standard in the industry to ensure that you can catch errors as soon as possible while affecting least amount of people. So what canary testing does, right? It begins with, let's say you have 100% of traffic going to the stable set of pods or stable set of application instances. Then you have started to release new software or new pods. What you need to do is you need to direct traffic to that new pod or new application instances in increments, right? So 1%, 5%, 10%, and you need to keep getting feedback with each increment that you're doing on what is the success rate, what is the error rate, or whatever golden metrics that your organization measures. And based on that, you fail or progress the deployment further, right? So that's what it's called, that's what it means by progressive delivery. You release a certain percentage, then you check if it is working fine, then you progress it further or roll back, right? That's how it works. So what are the benefits of progressive delivery? Of course, you will catch errors early, catch bugs early, so your SLIs and SLOs will be better. If you are a SaaS company, right, working with a third-party solution, if you're integrating with some solutions, it will be much better because you are bounded by SLAs, and every single SLA violation is a potential cost to the business. Reduces risk in the releases. You don't have to worry about, what if something may go wrong, right? If something does go wrong, which it may, you're gonna catch it very early and fail the deployment. Target specific audiences through multiple stages of releases. Now, as I said, right, GitHub, what it does is it first rolls out the change for its internal users, then specific members of the developer community, then specific members of third-party enterprise customers that they have, then they go all out, right, for everyone. So you can also target specific audiences using this canary releases that, okay, only customers with a specific segment, like, for example, for a edtech customer, you probably want to deploy it to some of your teachers first. Then you want to deploy it out to the students. And even when you want to deploy it to the students, you probably want to deploy it to some set of accepted beta testers, right? Before you deploy it to everyone. So this is exactly what you can do with progressive delivery. And it really helps kind of put everything together and make sure that things are fine as much as possible that you can do, right? Now let's talk specifically about Kubernetes. What is the benefit or what is the problem essentially in actually deploying things to Kubernetes? So Kubernetes has a concept of deployment and Kubernetes has a concept of pods, right? Now let's say you have a particular application, obviously it will be in HBA, but you have a particular application which will have 10 replicas, for example, right? Now what you do is you have done a kubectl apply. Let's say whatever your CI/CD tool is, it has done a kubectl apply. How does deployment do things, right? In a standard deployment on Kubernetes, you specify the rolling update strategy with max surge and max unavailable fields in it, right? And based on that, it will start to kind of launch one pod and start to delete other pods in the earlier deployment, which is a stable deployment. Now, as I said, right, let's say you had 10 pods running earlier in the stable version, and the new experimental version that you're launching, what it does, it will deploy one pod for that and remove earlier pod. So your final count is still 10 with one new pod and 9 older pods. So now how will your traffic distribution work? Because the Kubernetes service essentially does a round robin distribution, right? So it does send traffic randomly. So that means your traffic is now 90% to the old version and 10% to the new version. And as the deployment goes ahead, 80%, 20%, 70%, 30%, you see, you're not really in control here, right? You cannot go and say, I want only 1% traffic first. If you want, in our case, where you had 10 replicas earlier, and you want to deploy only 1% of traffic to the new pod, what you would have to do is you have to have 100 replicas for the older version and then start to launch one by one, right? To control at percentage layer, at each percentage layer, which would of course be very costly and impractical. So how do you do this? Enter service mesh. So what is a service mesh? So now of course, the application of service mesh are huge. This is one use case where service mesh really shines. Service mesh originally was designed to essentially abstract away all the networking logic out of your application at the infrastructure layer, right? So just imagine you have a chain of microservices, 50 odd microservices. Some are Java, some are Golang, some are Python, some are Node.js. They're all talking to each other, all communicating with each other and serving a particular functionality. Now, what you want to do is you want to ensure that there is no cascading failures, right? How do you do it? What you would have to do without a service mesh is you have to implement this rate limiter or circuit breaking logic at each microservice layer. Now, being developers, you're like, so what? What I'll do is I'll just create a central library. Then the developers of that microservice can just use the library. Sure. But again, in large environments with multiple tech stacks, multiple microservices, you not only have to create those libraries for each language, each tech stack, but also maintain them and then upgrade them, and then it's a lot of problem. And that's just one functionality, right? Which is circuit breaking. What about rate limiting? There's so many things that you have to do. What about MTLS, right? Mutual authentication, encryption of data between microservices. How do you do that? It's a lot of things that will, it's more of an infrastructure concern rather than an application concern. What should the developers be focusing on? Developers should be focusing on writing business logic, not MTLS or circuit breaking. So that's what service mesh is designed to do. What does service mesh do? How does it do it? So before we get into that, there are some examples, both open source and proprietary service meshes. Istio, Linkerd, these are an Nginx service mesh. These are all open source ones, right? Linkerd and Istio are CNCF based. Then you have Anthos, Glue, Console. These are proprietary service meshes. Now I'll just take the example of Istio and how that works, right? How Istio essentially does all this networking magic that we just talked about, what we just saw in previous slide. So think of it like this, right? You have three services: service A, service B, and service C, all written in different languages. Now each of them is communicating to each other for logic. Now it can be any sort of communication, right? It can be a REST call, it can be a GraphQL, it can be a RPC call. That's completely fine. What Istio does, it deploys a control plane in your Kubernetes cluster itself, and then what it does, it injects sidecar proxies in each pod that is part of the service mesh, right? So each of the different services, again, when I say service, I mean a deployment, right? An individual deployment. What you can do is you can annotate that individual deployment that, yeah, I want Istio to inject a proxy. So what it will do is it will launch a sidecar proxy alongside your pods, right? And now this proxy will change the IP table rules within that pod's networking namespace, and it will abstract away all the networking logic out of your code to the sidecar. This is completely without touching your code. You don't have to write a single line of code to do any sort of integration with Istio, right? Because it changes the IP table rule. So if service A is trying to call service B, what sidecar will do is when it tries to call the IP address of service B or the DNS name of service B, sidecar proxy will catch that, and it will do all of its magic that we just talked about, and it will go and communicate with the sidecar proxy for service B, and the sidecar proxy will do a local host call to service B and do all the magic there itself. So all of your traffic management and MTLS, fault injection, all of these things can be done directly at this service mesh layer. And how do you interact with service mesh? With simple Kubernetes YAML files, right? It basically exposes a bunch of CRDs for you to just modify and start using it. Now, there are two objects of note when it comes to Istio. One is a virtual service and the another one is destination rule. What is a virtual service? So everyone is aware of what is a Kubernetes service, right? Virtual service is nothing more than an abstraction or an expansion or superset of the service component itself. What does virtual service essentially do is virtual service allows you to specify the destination host and the traffic splitting pattern that you want, right? So for example, if service is communicating with service B, what we'll do is we'll create a virtual service, we'll create the virtual service and attach it to service B, right? We'll attach it to service B, and then we'll say that, what are the different logic that we want to do. So if, let's say, we want to do a circuit breaking or we want to inject faults into it, all of that can be done at the virtual service layer. What is the destination rule? Now, destination rule is actually what shines when we have to do progressive delivery, right? In destination rule specify two different instances of the same application, right? Okay, let's talk about it again. Let's think about it again. When you're deploying the newer version of your software, what you will do is you will deploy a new deployment, right? A new deployment, completely new. And then these two deployments, deployment A and deployment B for the same service, right? At the virtual service layer, you'll define that to deployment A, you send 1% traffic, to deployment B, you send 99% of traffic. And destination rule is what will allow that to happen. In the destination rule, you'll specify what destination refers to the stable version, what destination refers to the newer version. In the demo, I will show you the YAML file and how to configure that. All right. Let's put it all together now. There are two components. If you in my talk, there are two components that I talked about. Up until now, I just talked about what Istio is. So the other one is Argo. So Argo is not a project or a tool. Argo is a set of tools, right? It's a complete ecosystem of projects with multiple tools in it. There are many tools. So tool number one, which is Argo CD, which probably everybody has heard of now. It's like a de facto GitOps tool right now. The other one is Argo Rollouts. Argo Rollouts is the progressive delivery controller. So in Istio, as I said, in Istio you can allow to specify what percent of traffic will go to the new version, what percentage will go to the older version. But it's Argo Rollouts that allows for this automation that I talked about, which that is at 1% traffic, check what is the success rate. If the traffic is, if the success rate is greater than a certain threshold, you progress to 5%, then you progress to 10%, then you progress to 15%. So Argo Rollouts is the actual tool, and it's also a Kubernetes controller itself that actually allows you to do this automation and change the virtual service configuration on the fly, right, to ensure that this is happening, right? Without Argo Rollouts, you would have to write your own custom logic, which goes and integrates with Prometheus, which goes and integrates with, integrates with the API server, change the value of, the virtual service percentage traffic distribution, and essentially do all of this automation yourself. So Argo Rollouts does this very nicely. I'll just explain certain components, what is going on here. It's a very simple example. You have an ingress service and then a replica set. What Argo Rollouts, for Argo Rollouts, you have to create a new CRD called Rollout. So Rollout is a superset of deployment object. Instead of using the deployment object, use a rollout object. So simple, right? The deployment object to specify the image, the pods, the replica count, everything same here. But the rollout object, the strategy field in the deployment object, where you specify rolling update strategy, that changes completely. So in the rollout strategy, you specify how this progression will go. Okay? For how long should it stay at 1% traffic? For how long should it stay at 10% traffic? For how long should it... All is specified in the rollout object itself. Then rollout will create a new replica set. Okay? We all understand, right, that a deployment creates a replica set and the replica set actually creates pods. Same here. The rollout will create two different replica sets. One would be the stable replica set, and the other would be the canary replica set. And then you have something called as analysis template. Analysis template is where we'll calculate the success rate that I was talking about, right? You want to ensure that the new version is actually, its success rate or error rate is above or below a certain threshold. So in analysis template, define that I want to talk to Prometheus, get the success rate out, compare whether it is greater or lower than certain threshold, and then I will allow the step 2 progress, the progressive delivery to go on. If it fails at any point, fail the deployment, roll it back, right? So analysis template integrates with your many different monitoring softwares like Prometheus. It can also integrate with CloudWatch, with New Relic and multiple things, right? So this is how it essentially completely flows. Prometheus is very important. In my demo, I've used Prometheus for obvious reasons because it's much more industry accepted, right? So this is how it works. Now let me go and give you a quick demo. So I'll start with showing you how this entire pipeline is working. Then I'll break it down. I'll try to show you the exact code and what is happening. One second. I hope it's visible. Yeah, perfect. Okay. So I'll just first show you the actual application. Okay. I wrote this application last night. So please don't laugh. It's just a simple demo weather app, right? It's making a API call to a random open API. And during the course of this demo, it may also block me because of rate limiting. So if you see, it's just a simple demo weather app. The weather in New Delhi, it's showing what is the weather or temperature in New Delhi. It's 28.07 degrees, right? Now, obviously, we're in Bangalore. Why are we looking at Delhi's weather? So what I'm going to do is I'm going to just change this configuration from Delhi to Bangalore. That's it. Just think that I have done some big code change and now I'm going to deploy again. So instead of having New Delhi here, I'll just put Bangalore. Right, cool. Now what I'll do is I'll just commit this to my source code repository. Again, I am pushing it directly to main because it's my repository. Never push it to main. Push it if you wanna get push. Cool. Now it's pushed, right? Now let's go to Argo CD. We have so this is Argo. This is the Argo CD for people who have not seen Argo CD before. You see, already it shows that this is out of sync. I'll just do a quick synchronization for this. So what this sync will do is it will deploy this new application to my production environment or demo environment. So a quick synchronization. If you see, this is all the CRDs that is part of this. So if you see here, now this is the Argo rollouts dashboard over here. You see this. These are the steps that I've specified over here. So for the sake of brevity, what I've done is, you see, replica 4 is canary, revision 3 is stable, right? Both are running right now. And as it is passing the traffic, right? Now what I'll do is I'll also simulate the traffic quickly. Hope I don't get blocked by the, right? So apparently it passed the analysis as well. So this analysis, I will also show what I have done here. So it is passing. So right now, put it pause here. Ideally, what you should be doing is you should be having the analysis template, which is a success rate or error rate at each step. The reason I did it is because it's quick and dirty. Right now, the 100% traffic should be on my new version. So if I go back here, it should, if I reload by the power of magic, it should show the weather in Bangalore. It did not. Let me try again. Record your demo's voice. Okay. Apparently magic did not work. Okay, cool. So right now it should work. Yes. So what happened was that it basically waits 10 seconds before it actually starts changing traffic, right? So now this old deployment is going back, and if you see, the new deployment is marked as stable. If you see here, the rollback option is available directly. So you should not press it directly here, but in case of outages or something goes wrong, you can directly roll back from here. It also exposes an API, by the way, so you can create an automation workflow to roll back in case something has gone wrong. So now this new application is deployed, and this is Bangalore. We are at 28 degrees. Doesn't feel like 28 though. Cool. So this was the basic demo, right? Now I'll just show you the actual CRDs. Cool. So there are, as I said, right, there are 4 CRDs of note here. One is the rollout resource. The other is the virtual service, right? Destination rule and analysis template. 5. Cool. Let's talk about rollout first. What is rollout? So as I said, rollout is a drop-in replacement for deployment object in Kubernetes. What you do in deployment, you do exactly the same in deployment. Just by sheer mind power, just don't see the steps first. From here onwards, do you see anything different than what you would see in a normal deployment object? No, right? So it's everything is the complete same, where you specify resources, specify containers, labels, match labels, replicas. But instead of in the strategy field, right, instead of having your simple rolling update strategy, what the rollout object does is it allows you to essentially do it a much more complex and much customizable, right? So here in if you see the strategies canary, the traffic routing will use Istio. Istio is not necessary. You can use something like Linkerd, as I talked about, or any other service mesh. Or if you don't use a service mesh, you can use an Nginx ingress as well, right? It will not do 1%, 5%. It will do it like I talked about before, but it will automate the entire process, right? Istio, I've specified which virtual service is this going to be, which destination rule is going to be, and then here I've specified the entire steps, the steps that we saw in the Argo rollouts dashboard as well. These are the steps, right? Set weight, this 5 is percentage of traffic for duration of 10 seconds. And then here, analysis template, success rate, right? Now this is going to be of note. Here in this particular analysis template, what I've done is I've specified the success rate, which is how it is coming out. There's a Prometheus instance running, which is collecting the metrics from my applications here that are running. And what it is doing is it's sending a query here, right? It's a simple PromQL expression. It's sending a query, right, to the backend. If you see response code not equal to 5xx divided by total responses, right? That will give you success rate. And if that is greater than 0.95 for 3 trials, then this analysis run would be successful. That's how this will work. And this is what you should ideally, in the ideal scenario in production, you should specify for all of the steps, right? At each layer, you want to do this check for success rate, error rate. Again, any metric that you want to do, you can do it here. I have chosen success rate because for me, it feels most intuitive. But again, any metric that you have in Prometheus, because it's a simple PromQL expression that you run, right? It will send back a matrix, a vector, sorry. And if you see you can unpack that vector and do some sort of analysis on top of it, right? This is your rollout object. This is the virtual service for Istio, right? This particular thing, where what it will do is the gateway that we'll use is the Istio ingress gateway. The host is the backend service, which is your service, right? Which is the application service. As I said, you want to attach it with service B. Name of this would be primary, this particular service, port, and the subset is stable and canary, right? So if you see, I have put 100 over here, and for canary, the weight is 0. So this is how this will start out when the progressive delivery starts. With each step that we saw here, right? With each step that we saw here, the rollout object, Argo rollouts, will change this exact thing from 100 to 95.5 to 95 to 90.10 to 85.15, whatever that you've specified it. It will keep changing this, and because it keeps changing and applying this, it will happen, right? And in the destination rule, you specify how you will define as particular destination, right? The subset is canary. Again, the label is the backend label that you specified. So that's how it essentially takes the entire thing to its fruition. And if you see here, again, let me just go back to the presentation really quickly. Right. So if you see, the rollout object created 2 replica sets when we deployed. It automates the distribution of traffic using Istio's virtual service and destination rule to canary and a stable replica set based on the analysis runs or an analysis templates that happen, and calculating the success rate from your metric server like Prometheus or Neuralink or any of those, right? And yeah, that's how it essentially deploys it in phases and progresses the delivery, right? That's the entire point of progressive delivery. Yeah, I think that's been it. That's my talk. Demo time is done. Yeah, so if anyone wants to connect with me, just follow this QR code.